Hello all, welcome to Pivot Point. I hope that you are doing well and following along with this playlist. Today we are going to discuss one of my favorite topic in this playlist, which is principal component analysis. This topic in machine learning is as important as confusing for the beginners, and the only agenda of this lecture is to simplify this topic for you as much as possible with the help of simple examples. So without any further delay, let's get started. So without discussing any kind of mathematical term or machine learning topics, first I want you to participate in this activity. So as we can see, we have a picture on the screen which is drawn by me, and we have few houses and trees within the frame. And for a minute, let's assume that instead of watching it on your screen, you are standing here on this position on this 2D surface. And standing on this particular point, if I'll ask you to get all the information of what you see from your point of view, then still you will be able to cover a lot of things, houses and trees, but you will also end up missing out few information like this tree, for instance, behind the house, this tree, and also this one. You also might not have a proper view for this house or this house, for instance, because a lot of things or objects in the front are blocking the view. And now let's say you change your position over here on this point, and most probably now you will be able to cover a lot of information which was not visible to you from this point here. Like for instance, you will be able to see the information for this house and tree and this one as well. However, you will still miss out on a lot of information like this tree right here, which is hidden behind the house, also this tree over here, and most probably these houses as well. So even though after changing your position you are discovering few new things, but again you are missing out few things which was visible from the previous position. And similarly, if you keep on changing your position to this place right here and then over here, then by the end you will have a 360-degree view of this entire frame. You will have the information for all the houses and trees and their location. Although it was not possible to have all this information from any one particular location, let's say two of these locations for instance, but after having a 360-degree view, now you have covered everything within this frame, and this is what we ultimately want. But now here we have a problem of overfitting. For those who have a machine learning background are already familiar with the term overfitting, but still who are not aware, I will give a super quick explanation. So by saying overfitting, what I actually mean is that although you have the information and all the details from this picture frame, however, there is too much dependency. And it is because without covering this view from all the angles and all the possible directions, you will definitely miss out some or the other information within this frame. However, in reality, when you are watching this picture frame on your computer or mobile screen, you don't have to revolve around this location in order to grab the entire information out of it, because you're standing on such a point where from one particular location you can see or have all the details within this picture frame. And this could be considered as one of the most simplest example of dimension reduction. So changing our position to a 3D view to our digital screen, we are no longer dependent to have different views around this picture. And now if we switch our gears into machine learning, then let's consider a use case where you have, let's say, 5 features. So I'll write F1, F2, F3, F4 and F5. These 5 features in order to detect or predict the target column, let's say that is price. And let's say we want to reduce this number of features into smaller dimension. Let's say we want to keep only 1 or 2 features out of it. In that case, principal component analysis is one of the dimension reduction technique which is most often used in machine learning. So let me also tell you that in order to keep only 2 useful features, it is not that we are grabbing 2 features from here and eliminating rest of the 3. In fact, with the use of linear algebra concepts like eigenvector, eigenvalues, vector norms, etc., we are creating 2 new features which retains most of the useful information from the previous 5 features. And these newly created features are called principal components. Another thing to understand is, let's say that we want to keep 3 principal components. In that case, the first principal component will contain or retain most of the useful information from the previous set of features. The second principal component will then contain the second highest useful information from the previous set of features, and then so on. And now let's quickly jump into the Jupyter Notebook, where we are going to have a practical demonstration to have a stronger grip on this topic of principal component analysis. So from the sklearn module, I'm importing datasets, which is a library where a lot of typical datasets like iris flower, breast cancer, etc. is stored. And here within this iris variable, I'm storing the iris dataset, but you can see I'm loading the iris dataset. If we check the shape of this iris dataset, it has 50 records and 4 features, and these feature names are as follows. So we have sepal length, sepal width, petal length, and petal width. If we have a look on the top 4 records of these features, it will look something like this. So depending upon the information provided in each and every record, a machine learning algorithm will decide that what kind of flower it is. And then I am importing this principal component analysis function from sklearn.decomposition. And in the following cell, I am mentioning that I want to keep only 2 principal components, which essentially means that out of these 4 features, I want to retain most of the information and compress it into 2 new features. So again, I'm mentioning that it is not that out of these 4 features we are going to eliminate 2 and we will keep 2. In fact, principal component analysis is going to create 2 new features that will retain most of the information from these 4 features. And in the following cell, I am storing these principal components into a variable x. If we check the shape of x, then you can see it has only 2 features and 150 records as earlier. And these 2 new features look something like this. So you can see again I am checking the top 4 rows of the features, and this is completely different to what we had in the top 4 examples of our previous set of features, which essentially means that these 2 features that we have are absolutely newly created. And in the following cell, I have tried to plot these 2 features on a scatter plot, and at the moment this might not make that much sense to you that how these 2 new features are helping us in order to identify the flower within the target column. So as you can see in the following cell, we also have a target column which has 150 records, and the first 50 records belongs to one particular type of flower. Starting from 50th to 100 record belongs to another type of flower, and then from 100 to 150 is a different type of flower. And the flower names are as follows: Setosa, versicolor, and virginica. And in the following cell, I am again plotting these 2 newly created principal components and color coding them going by the flowers from the target column. And as you can see, although we have reduced the number of features from 4 features to only 2 principal components, but still how nicely it retains and clusters the 3 types of different flowers on the scatter plot. And this is how simple it is to implement principal component analysis with the help of a Python library. And now, since we have already covered this practical part, the theory part will make a lot of sense. So as we know so far, principal component analysis is a dimension reduction technique. It is also referred as a machine learning algorithm, but I don't prefer to call it as an ML algorithm because logically it is more of a dimension reduction technique. It uses the concepts like eigenvectors, eigenvalues, norms, orthogonal and identity matrices, and trace operators, etc. All the topics that we have covered within this playlist. So if you're someone who is not familiar with all these terms, then let me tell you that I have uploaded very simple explanation for all these topics within this playlist only. You will find the link within the description box, or you will get a card somewhere on the screen. Please do check out the playlist, and I promise that you will not regret. So as we have seen in the Jupyter Notebook, the principal components retains most of the useful information and reduces the number of attributes or features or columns, you can say, at the same time, which is also called a lossy compression. So we are compressing the number of features or attributes by making sure that we retain most of the information out of the previous set of features. It tackles overfitting, of course, because our model is no longer dependent on too many features in order to make a prediction, and all the principal components are orthogonal to each other. It is a very important thing to remember that all the principal components are independent of each other. And this is the final part of this lecture. and very important as well, because although in data science when you work with principal component analysis you implement it very easily by writing few lines of code, but when you appear for an interview, especially for a good company, maybe a product based company, most probably you will be asked this question, that what are the step-by-step procedure for calculating the principal components. So the first thing is that the standardization of data is important. So you can simply do it by using a min-max scaler or standard scaler. Then it computes the covariance matrix for all the features in the previous set of attributes, and after computing the covariance matrix it does the computation for the eigenvectors and eigenvalues, and with the help of that our new principal components are obtained, and this is how we reduce the dimension of the data. Although nobody is going to ask you to do all these calculations manually on a pen and paper, but still, in order to establish yourself as a good resource for any company, you should have some understanding that even behind a one line of code, what is actually happening in order to gain an intuitive understanding. So that is it for today's lecture. I hope that you found it useful. If yes, please consider dropping a like below. Also subscribe to the channel. And in the next video, we are going to cover the vast topic of calculus in a very simple and intuitive way. Thank you very much for your time today. See you in the next lecture.